Okay, so today we're going to be looking at percent of change problems. Percent of change. So normally when we talk about percentages, we're talking about part of a whole or is over of. And when we talk about those kind of percentages, those cannot be percentages over 100%, and they can't be negative. Right? But when we're talking about percent of change, we're talking about how much something changed. That percentage can be negative, and it can be over 100%. So have you ever heard people talk about, like when they're talking about financial reports or, especially now starting the year, they'll talk about their growth from one year to the next, and they'll be like, we grew by 40% this last quarter. Or it was a 30% drop. Or sometimes you can grow by, like I said, percentages over 100. Like you could have 150% growth. That's pretty good. That means you more than doubled. 100% growth means you doubled what you used to do. So like if you were mowing yards for a week or something, and say one week you made $100 and the next week you made $200, then that means that second week you had 100% growth from what you had the previous week. 150% of the $100 would be $150, but 150% of 200 would be 300. Yeah. So, no, that's wrong. It would be, if you were doing 150% growth of 200, that would be $500 because you'd have to double it and then half. But that's what we're going to go over is those percents of change. Okay, so it says the table shows about how many people attend home football games of a high school football team each year. So you'll see in 2007 they had 16.6 thousand. 2008, 16.4 thousand, and so on as you go down the chart. Now they want to know how much did the attendance increase from 2009 to 2010. So that's not a rate, that's not a percentage. We just want to know how many more people came in 2009 to the football games than did in 2010. So what we would do there is we would just subtract. So how many people came in 2010? 17.4 thousand. And then we subtract how many came in 2009? 16.9. And that gives us a value of 0.5 thousand. So that's half a thousand or 500 people. If that's what 0.5 thousand means. It'd be 500 people. Second one. Write the ratio, the amount of increase over attendance in 2009. Then write the ratio as a percentage. So this is kind of our introduction into percent of change. So the amount of increase was 0.5, right? So instead of amount of increase, we're going to put 0.5 over, and then what was the attendance in 2009? It was 16.9. So we would do 0.5 over 16.9. That's it written as a rate. Now they want us to make that a percentage. So I would put that in my calculator. 0.5 over 16.9. Because you're not going to want to divide that if it's not. That's going to be ugly to divide without a calculator. Eugene, poor Eugene. That's going to give me 0.0296 if I round when I divide those. So that is it written as a decimal. Does anybody remember how do we go from a decimal to a percentage? We move the decimal 2 places to the right, and this becomes 2.96%. So that means the growth from 2009 to 2010 was a 2.96% growth. So how much did the attendance increase from 2008 to 2009? Well, see, that's just doing it again. And then you'd be finding a different percent of change. So, again, this is kind of the steps we do when we're finding the percent of change. How much did it change from one year to the next? Okay, so what we did there, we first subtracted the original amount from the final amount, and that gave us the amount of change. When you compare the change to the original amount in a ratio, you find what's called the percent of change. So right here is the formula we're going to use for percent of change. It's equal to the final amount minus the original amount divided by the original amount, and then we're going to multiply by 100 to make it into a percent. Or otherwise, we're going to move the decimal 2 places to the right. That's what multiplying by 100 does. So you'll hear me say that a lot. Final minus original divided by original to find that percent of change. Positive or negative. Okay, so here's our first problem. It tells me to find the percent of change in the cost of gasoline from 1970 to 2008. Round to the nearest whole percent if necessary. Then state whether the percent of change is an increase or a decrease. So I know my percent of change formula. Again, I'm just going to write it down here. It is the final minus the original divided by the original. So out of these two prices, one was in 1970, one was in 2008. So which one of those would be the original price of gas? 1970. The older one is going to be the original, which means the 2008 price of gas is our final price of gas. So now when I plug those in, it's going to be final, which is 3.95, minus the original, which is 1.30, divided by the original, which is 1.30. And then again, we're going to multiply it by 100 to make that into a percentage. So again, using my calculator, 3.95 minus 1.30, that gives me 2.65 divided by 1.30. So then when I divide those, that gives me 2.038. And that's written as a decimal. So to make this into a percentage, we move the decimal 2 places to the right. So that's 203.8%. But then they told me to round to the nearest whole percent. So 203.8 would round up to be 204%. So there was a 204% increase in the price of gas from 1970 until 2008. Okay, here's our next one. Yusuf bought a DVD recorder for $280. Now it's on sale for $220. Find the percent of change in the price. Round to the nearest whole percent if necessary. Then state whether the percent of change is an increase or a decrease. So again, if my percent is positive, it's an increase. If it's negative, it's a decrease. So out of these two, 280 and 220, which one was the original price of the DVD recorder? 280 is what it was originally. Which means the final price is 220. So then when I plug in, remember I do the final minus the original divided by the original. So what is my final price? 220 minus the original price is 280 divided by the original price, which is 280. So now in the numerator, what is 220 minus 280? It's going to be negative 60 because the original is more than the final. So because it went down in price, we expect that change to be negative over the original, which is 280. And now we'll put this in our calculator. Negative 60 divided by 280. When I put that in, I get a decimal number that is 0.2143. And again, this is a decimal. To make that into a percent, I move the decimal 2 places to the right, which means it's 21.4%. And then it tells me again to round to the, I'm sorry, this should be negative. I forgot the negative on all these. It tells me to round to the nearest whole percent. So 21.4 would round down. So that's going to stay at negative 21%. So the DVD player had a percent of change of negative 21%, which we know is a decrease because it's negative. Which one was the final value? 13. Okay, 13 is the final, which means 10 is my original. So you plugged in, I guess, final minus original divided by original. All right, and then what numbers did you get here? Did you put it all in your calculator?
No.
Or you didn't get anything?
I didn't get it because I don't get it. Like, I need you to explain it to me again.
Okay. So you good with the final and original price?
Mm-hmm.
And you good with the formula? So when you plug into the formula, all you do up top, 13 minus 10 is 3 over 10. And I'll put that in your calculator. Put 3 over 10 in your calculator and get a decimal number. So when you do 3 divided by 10, you should get 0.3. Did you get that?
I can't put that in my calculator.
You can.
I can't do that.
You can.
Put ABC. No, just
B dash B.
no, just put 3 multiplied by
Yeah, clear. Clear. Hit 3.
that's all.
There's your fraction right there, ABC.
What do you
And
do?
then
15 times 40.
That's what that
10.
means.
Yeah, that means a fraction. Click equals.
I know.
And then you can click, click equals again, see if that does.
Jeez,
I'm trying to remember. Maybe you can't change which one. The way that you can make yours, so if you wanted a fraction answer, you use that fraction button. Since we want a decimal answer, the same thing is this. That means fraction. So when I put 3 divided by 10, it'll give me a decimal like that, 0.3. And so that's our decimal answer. But again, we want to make this into a percentage. So we would move the decimal 2 places to the right, or you could think about it as multiplying by 100. So 0.3 times 100 is 30%. Now, is this an increase or a decrease?
Increase.
It should be an increase because it's positive. It went up by 30%. Let's look at B part. Pick a number, 1 through 6. It's 2. Okay, what'd you get on B? So first, which one is the original price?
The original is 20.
The original is 20, which means 15 is my final. So I would assume when we plugged in, we got final minus original divided by original. Okay? So now 15 minus 20 is negative 5 over 20. And then when you divide that, you got, okay, that's backwards.
Negative.
If you do 20 divided by 5, you get 4. We're doing 5 divided by 20. There'll be negative 0.25. It's a fourth. Okay? So make sure you're careful. Remember, when you plug these into your calculator, it's always the number up top divided by the number on bottom. It's not always the bigger number divided by the smaller number. It's the numerator divided by the denominator. Now, negative 0.25, we make that into a percent. So 2 places to the right, that's going to give me negative 25%. Which one's original?
30.
Yep.
And
Which
I
one's
divided-
okay? You divided what?
I divided 30 and 24, and I got 1.5.
What's the formula? Final minus original.
Oh, that's what I got wrong.
Divided by original.
And I got 1.25. And then that's where
It's not gonna be you. It's not gonna be 1.25 because you didn't never subtract. You didn't use this formula. You just divided the numbers. You told me what you did, so all your numbers are gonna be wrong. 24 minus 30 is negative 6. Negative 6 divided by 30 is
negative 0.2.
negative 0.2. And now we want to make this into a decimal. I'm sorry, into a we want to make this decimal into a percent. So we go 2 places to the right. So we should get negative 20%.
I felt like, okay, so I started off by subtracting, and then I figured I was supposed to get a decimal number, so then I just divided.
Well, that's why I wrote that formula down, if you remember, and I told you you're going to have to use it a lot. Final minus original divided by original on every one of these problems. Pick a number, 1 through 6. Pick a number, 1 through 6. It's 3. Pick a number, 1 through 2. It's 2. So which one's the original? Yep. So when we plug in, we should get final minus original divided by original. So 35.5 minus 20.5 gives us 15 over 20.5. Then what do you get when you divide that?
Oh, wait, 0.73, a bunch of numbers.
0.731. Then we go 2 places to the right to get 73%.
I put 2 numbers. Oh,
That's okay. You got to round to 2 anyways. So
who's this one?
yeah, wait till I finish the next 2. Okay, 3. Which one of those is the final price?
150.
150 is final. 126 is original. So that's going to be final minus original divided by original. So that should give us 24 over 126.
Zero
0.19, and then I make that into a percentage, which is 19%. And then on 4, 20 or 75.80 is the original, 94.75 is the final. So it's going to be final minus original divided by original. That gives me 18.95. And then it's be divided by 75.80. Which is 0.25. Move the decimal 2 places to the right. So that's 25%. Do we feel any better about how to do these? Okay, let's go over the answers real quick. What did we get on 6? You got what? 20%? On 7, 40%. On 8, negative 50%. And then on number 9,